This is Microelectronics 1. This course talks about three main electronic components, and these are the operational amplifier, the PN junction or the diode, and then the bipolar junction transistor. So these are three main electronic circuit components that we are going to talk about. So first, let's take a look on the aim of this course. First, the aim of this course is to study the characteristics of the most famous and used electronic component, and this is the operational amplifier, the op-amp, and its applications. So that actually means that we are going to study the characteristics of this operational amplifier and how to calculate the resistors that we are going to add into the circuit of the operational amplifier. And also we are going to study the application circuits of this operational amplifier and where do we use this component. So this component is one of the most used components in any electronic circuit, and this operational amplifier actually is for amplifying the signal. Okay, so we have an input signal and output signal, and this operational amplifier amplifies the signal. Then we are going to provide essential understanding of semiconductor device characteristics. So semiconductor device characteristics are the PN junction and the bipolar junction transistor, aka meaning the diode and the transistors. So we are going to talk about these two components. So that means that we are going to provide essential understanding of these semiconductor devices. Okay, so we are going to talk about the characteristics of these devices, testing, and the practical circuits in which they are found. So the course topic. So the topics in this course are chapter 1 and chapter 2 are going to talk about the basic operational amplifier. Okay, so we are going to talk about the operational amplifier in theory. Okay, we are going to learn how to calculate the calculations of this operational amplifier, then the applications of the op-amp, where do we use this op-amp, and the circuit in which we use this operational amplifier, and how to insert this component into the circuit. Chapter 3 talks about the PN junction, aka the diode. Okay, so this talks about the diode. So we are going to talk about the PN junction, the diode, and the PN junction applications. So we are going to talk about the diode in theory and the applications of this component. Then we are going to talk about the bipolar junction transistor, okay, and the bipolar junction transistor DC analysis. So we are going to learn how to analyze the signal that comes out from this bipolar junction transistor. Chapter 5 talks about the junction field effect of the transistor, the J-FET transistor. Okay, so this course actually talks about all of this components. So these are essential components used in any electronic circuit. So these are some of the most used electronic components in the circuit. So we are going to talk about the calculation of these components, the insertion of these components in the circuit, and the resistors that we need to connect with these components, and the values of these resistor, etc. Okay, so this is the content of this course. So first, let's talk about the ideal operational amplifier. The ideal operational amplifier circuits are: an operational amplifier is an integrated circuit that used to amplify the difference between two input voltage signal. So that actually means that the operational amplifier is used to amplifies the signal, okay, the difference between two input voltages signal. So this actually means that the operational amplifier is an integrated circuit. It is an IC. So the operational amplifier is an IC. This IC, okay, amplifies the signal that comes from the input to and go to the output. So that means that the signal goes from the inputs in some value, and then it's going to be amplified in the other output. Okay, so right here we have two inputs. Okay, the amplifier, okay, the amplifier amplifies the difference between these two inputs. We have input 1 and input 2, so the amplifier amplifies the difference between these two inputs and give us the output from the other pin. Also, the term operational amplifier comes from the original applications of the device in the early 1960s. So this actually means that the term operational amplifier comes from the original applications of the device, because this device used in amplifying the signal, or also used in the amplification circuits. Okay, the amplification circuits used, for example, in the speakers. Okay, we have speakers. These speakers takes the signal from our phones, from AUX cable, and then amplifies this signal to go to the speakers. This topics includes, so the ideal operational amplifier topic includes discuss and developments parameter and characteristics of ideal op amps. Okay, so we are going to talk about the developments parameters and the characteristics of this ideal operational amplifier. The ideal operational amplifier is a theoretical operational amplifier that is perfect without any errors. So this is the ideal operational amplifier. So first we are going to talk about the characteristics and the parameters of this ideal operational amplifier. Second, we are going to analyze and understood the inverting and non-inverting operational amplifier circuits. The inverting and the non-inverting operational amplifier circuits, that means that we could invert the signal that comes from the input to the output, or we could not invert this signal. Then we are going to talk about the summing operational amplifier circuit, voltage follower, or the buffer. Then we are going to talk about the difference amplifier and instrumentation amplifier. So the difference amplifier and the instrumentation amplifier are two different things that we are going to talk about them in details in the next few lectures. So the operational amplifier symbol and terminals. Okay, first we have the small signal circuit symbol. We have, this is the symbol, okay, of the operational amplifier. This is a very simple symbol. Okay, this symbol have right here, we have right here the two inputs, okay, V1 and V2, and we have right here the output. The plus meaning that this is an a non-inverting input, and the minus means that this is an inverting input. As you can see that the operational amplifier with positive and negative supply right here. Okay, so this is the most complicated, or the other detailed version of this symbol. This right here, we have the V number 1 and V number 2. So input 1, input 2, we have right here is the minus. So the minus means that this is an inverting input. We have right here the positive, and the positive means that this is non-inverting input. So also we have right here the positive and negative. These positive and negatives are two pins that goes to the power supply. Okay, so these two pins are going to the power supply, one for the 5 volts or 12 volts depending on the type of this operational amplifier, and the negative goes to the ground. We have right here is the output that we take from the amplified signal. As you can see that right here, this is the equation from which we calculate the gain that the signal takes when it is going from the output. So right here we have the V node. The V node actually is the V output. It is the voltage output. This equals to A. A actually it is the gain. Okay, the gain that the signal takes, okay, to be amplified. So that actually means that if the signal is, for example, 5 volts, okay, the gain is the number that is multiplied to the signal to give us the output needed. Okay, so as you can see that this is the output voltage. Right here we have the gain, and these two are the difference between the two inputs. Remember that we have talked about that the operational amplifier actually amplifies the difference between the two pins. So that actually means that the V plus is the V number 2 or V number 1, the input, the first input, and V minus actually is the second input. So the difference between these two inputs are the signal that we are going to multiply to the gain, and then as you can see we have our amplified signal. Normally 20 to 30 transistors are needed to build up one operational amplifier. Actually that we have right here that 20 to 30 transistors are used to build an operational amplifier. So that actually means that there we have right here a lot of transistors inside the operational amplifier. The operational amplifier IC packaging. So we have talked that this is the operational amplifier. Actually it is an integrated circuit. So the IC packaging, as you can see, this is one of the most famous and used operational amplifier, the 741 operational amplifier. Okay, we have right here that we have this is the operational amplifier. We have the inverting pin, the non-inverting pin. We have also right here that we have the power, okay, the VCC. We have the V plus that goes to the 5 volts or the 12 volts, but actually right here this IC takes 5 volts as a power supply. We have right here the V negative, means that this is going to the ground, and right here we have the output. This called offset null, and this also called offset null. Actually that means that these two pins are not connected to anything. So these two pins aren't going to be connected to anything because they aren't connected inside the IC. And also the same with this pin. Okay, so as you can see that the inverting input, actually it is the pin number 2. The non-inverting input is the pin number 3. The output pin, actually the pin number 6. The positive power supply, okay, is pin number 7. Negative power supply is the pin number 4. The ideal operational amplifier properties. So this is the ideal operational amplifier. So this actually means that this operational amplifier is a theoretical operational amplifier on paper. So this is some calculations, or this is some properties of an we could say that this is an imaginary operational amplifier, because this operational amplifier has no errors, and this is not a thing that exists in real life. In real life, any electronic components has errors. So in the ideal operational amplifier, this has infinite voltage gain, okay, and also have infinite bandwidth. Also it has an infinite input impedance. So the input impedance actually is the resistance, okay. There is a resistance in the input pins. So between these two pins there is actually an impedance or a resistance, okay. So the resistance between these two pins is an infinite resistance. This is actually not existing in the real life operational amplifier, but it is a very high resistance, okay, between the two pins of the inputs, okay. And also it has a zero output impedance, okay. There is right here a resistance, okay, in series with the output pin, okay. So the output pin, before the output pin there is an resistance that are connected in series with this V output, okay. So this resistance is a zero resistance or zero impedance, but this is also an imaginary number. That in real life there is actually resistance, and this resistance varies between 40 ohms to 100 ohms, okay, but that means that this also is a very low impedance. The practical operational amplifier, or the operational amplifier in real life, okay. This operational amplifier actually exists, and this operational amplifier has errors. So This operational amplifier has very high voltage gain, but not infinite, and has very high input impedance, but also not infinite. Very low output impedance, but not zero, like the ideal operational amplifier. We have a wide bandwidth, but not infinite, like the ideal operational amplifier. We have also output saturation. What is the output saturation? So we have talked about these 4 points. We know what is the voltage gain. The voltage gain is the gain that the signal takes to be much amplified. Okay, and number 2, we have the very high input impedance. The very high input impedance, we have talked that there is a resistance between the two inputs exist on the operational amplifier, and this is a very high resistance. We have also resistance connected in series with the V output, and this resistance is a very low resistance, but not zero like the ideal operational amplifier, or the what's that I like to call an imaginary operational amplifier. And also it has a wide bandwidth, okay, not infinite bandwidth like the ideal operational amplifier. So what is the output saturation? There isn't any output saturation in the ideal operational amplifier. As you can see that there, we haven't talked about the output saturation. So what is output saturation? Because the practical operational amplifier takes power supply, okay, so the power supply that this operational amplifier takes, for example, as you can see right here, we have a power supply right here. It goes to the 5 volts, and here is going to the ground. So actually that the maximum voltage that this operational amplifier could take or could possess is 5 volts. So that means that the signal, okay, let me just go to this whiteboard. The signal that goes to the operational amplifier actually like this, okay. The output that comes from the operational amplifier, okay, is going to be like this, okay, a very high signal with very high values. But we have said that this operational amplifier takes 5 volts, okay, from the power supply. So that actually means that the maximum value that the signal could take is the 5 volts. So that means that if we are going to gain, or we are going to give gain to this signal, and the maximum is going to be, for example, 6 volts, that is not going to happen. As you can see that this is not going to happen. Why? Because the maximum voltage that the operational amplifier can take is 5 volts. So that means that the volts is not going to be like this. It's going to be like this. It's going to be cutted from the signal. As you can see, it's going to be 5 volts right here. So this is what's so-called voltage saturation. So the voltage saturation is the maximum voltage that the operational amplifier can get, and the gain of the signal cannot exceed this value. So the amplified signal cannot exceed the value of the power supply. This is what's so-called the output saturation. The ideal versus practical operational amplifier. So the ideal, okay, has we have talked about the ideal. The ideal has sorry, I guess. Okay, the ideal operational amplifier, in case from the differential voltage gain, it has an infinite voltage gain, but the practical operational amplifier varies from 10 power 5 to 10 power 9. The bandwidth, okay, gain is infinite in the ideal operational amplifier, but in the practical operational amplifier it varies from 1 to 20 megahertz. The input resistance, okay, the input resistance or the input impedance is in the ideal operational amplifier, it is an infinite, but in the practical operational amplifier, it varies from 10 power 6 to 10 power 12 ohms. The output resistance, it is zero in the ideal operational amplifier, but in the practical operational amplifier it varies from 100 to 1000 ohms. The CMRR, okay, this is in the ideal operational amplifier, it is infinite, and this is actually what the saturation stands for. And in the practical operational amplifier, it varies from 10 power 6 to 10 power 9. We are going to talk about the operational amplifier operation modes in the next lecture. That's it in this lecture. Thanks for watching, and I hope to see you in the next one.